Okay. I've been watching or looking at some of your homework and answering some questions from some of you. So I wanted to go through and help you understand the first couple of problems because there apparently seems to be some confusion on those. We went through these in class the last time we were here on Wednesdays, or the last Wednesday we were here. So we've talked about how to do this, but it looks like there's still some confusion. So we're dealing with the fundamental counting principle on the first two problems on that homework assignment. I think the homework assignment says something about there's 3 numbers and 4 letters that can be reused or not reused, which basically just means that we either, for the first one, the first number, we have 0 through 9 available. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we can reuse it, all 10 numbers are available again the next time. And so on. If we can't reuse a number, if I use 0 for the first digit, 0 is not available for the second one. So how many do I have then? Now I have 9 available. So 10 times 9 times 8. Same thing with the letters. There's 26 letters in the alphabet. So the first time I have a letter available, I have times 26. So 10 times 9 times 8 times 26. If I can't reuse, and I have to have 4 more letters, now I have times 25 times 24 times 23. It goes just to this thing that we talked about. If I have 2 flavors of ice cream and 5 different fruits and 3 different nuts, I have 2 times 5 times 3, which is 30. So here's one similar. If I have a password and it consists of 4 digits followed by 2 letters, the letters A and Z are not used, and each digit or letter may be used more than once, which means I can reuse everything. The only 2 I don't use are A and Z. So for the first number, or the first digit, how many do I have available? I have 10. How many do I have for the second one? 10. The third 10, the fourth 10. So I have 10 times 10 times 10 times 10. Now I have letters, and I need 2 letters. Since there's 26 in the alphabet, and I can't use 2 of them, I have 24. So times 24 times 24. And my answer becomes 5,760,000. If you go through the PowerPoint, you would understand this. You have to go through the PowerPoint and the material in this process, or it's not going to work for you. Most of you just want to jump on and do the homework. It's not going to work for you that way. Some of you it may, but for the large majority, you're going to have to go through the material. You're going to have to try and find a video. You're going to have to ask me a question, ask me to make a video about it. We can do all that. But you're not going to just be able to do it. So let's look at this one on your PowerPoint. To make your own adventure, a story lets you choose a starting point, gives you 4 plot choices, and then 5 possible endings. How many adventures are there? Well, 6 times 4 times 5. So there's possibly 120. So now we have a password that is 4 letters followed by 1 digit. Uppercase letters A and lowercase letters may be used, and they're considered different. So now I have 10 digits to use, and I have 52 letters to use. So 52 times 52 times 52 times 52 times 10. 73,116,160 possible passwords. Okay, so keep going through this. Now, where this becomes important, I'm not going to go through that, is here. It's a permutation is what you're working on. We talked about factorials. We talked about all of this stuff right here. This is the one that you're struggling with. Sometimes you may not want to order an entire set of items. Suppose you want to select and order 3 people from a group of 7. You can use permutation. So the choice of the first person there is 7 possible people. Well, if you've already used one of those people, now there's only 6. And for the third person, there's only 5. So 7 times 6 times 5 is 210 permutations. That's the problem you guys are struggling with. One of them you can reuse. If it said that one person can be in more than one spot, it would be 7 times 7 times 7. So that's the difference between reusing numbers and not reusing numbers. So we could do it this way. We could use a number of arrangements. We could use the permutation formula. The number of arrangements over the number you need, or the number of people over the number you're looking for. So if there's 7 total people and we have 4 ways to arrange them, and order does not matter, 7 times 6 times 5, because your 4, 3, 2, 1 canceled out. You just need to use permutations as part of the fundamental counting principles. If you have more questions, send them to me, write them into your Google Classroom, and I will make you another video talking about that. I hope this helps. Let me know.